Okay then, so last lesson we talked about electrolysis. We need to remind ourselves that electrolysis means the breaking down. This lysis is breaking down substances into simpler substances using electricity. Okay, so this is referring to the electricity. So electrolysis is breaking substances down using electricity. Remember, when we start to break these down, the substances have to be ionic, and in order for the electricity to pass through them, they either need to be molten or dissolved in water. Okay, the reason they have to be this, you should be asking yourselves that question. Have a little think, why do they have to be molten? Why do they have to be dissolved in water? We need a couple of seconds just to have a quick think. And hopefully you've identified the fact that the lattice, the ionic lattice, has to be broken so that the ions are free to move. Okay, so the lattice has to be broken so the ions are free to move about, and that means that they can move towards the anode or the cathode inside the electrolyte, which is the substance where the ions are able to move about in. Okay, first bit done. Okay, so let's have a look at a quick example, and here is going to be my example. An example we're going to look at is sodium chloride, and we're going to take sodium chloride, and what we're going to do is we are going to make it molten. So it's going to be in effect in a liquid state. So this is going to be molten sodium chloride. Okay, so if we have our electrodes, here's 2 electrodes, and we're going to put these inside a container, and then there is the top, and remember this has to be linked to a DC power supply, and that means that one side is going to become negative and one side become positively charged. We've got a positive and negative electrode. Right, inside the solution we will have sodium ions, and let's do a couple, and we will also have chloride ions, Cl minus. Let's have another one over here, Cl minus. So what we've basically done is if we go back up to here, we've taken the sodium chloride and we have broken the lattice to form sodium ions and chloride ions, and those ions now are inside this solution and are free to move about. So again, a little bit of thinking time. Where are the sodium ions going to move to? So this sodium ion, because it's positively charged, is going to migrate towards the negative electrode, and this one, as will all the others, will do the same. So the sodium ions migrate towards the negative electrode. That means that this negative electrode is attracting the positive ions. Remember the name for positive ions? The positive ions, these are called, put it in red for you, these are called cations. Cats and positive, I love them, that's how I remember this. So the cations head towards this negative electrode. This electrode, therefore, is called the cathode. So at the cathode, let's have a quick look down here. What's going on at the cathode? At the cathode, the sodium ions are arriving, they're migrating towards there. And what we want to be able to do to these ions, we want to be able to convert them into sodium atoms. We want to be able to convert them into sodium atoms. How do we get something that's positively charged and make it become an atom which has no charge? The way we do this is these positive ions pick up a negatively charged electron, and they then become a sodium atom. So that means at this electrode we are going to start to produce sodium, use it from our sodium ions. Okay. At the anode, let's have a quick look at the anode. So the anode, we've got our negative ions. They're going to head the opposite way, so they're going to come around this way. They're going to migrate towards the positive. Again, opposites attract, that's why they're going to head that way. And the negative ions are called anions. So these negative ions are called anions. Our way to remember that was if we write it like this. The N indicates they're negative, so the negative ions are migrating that way. And because they're migrating towards the positive electrode, the anions, this is called the anode. Okay, so underneath here, let's have a quick look at the anode. There's our cathode, here's our anode. So at the anode, our chloride ion arrives. Now again, what we want to do here is we want to convert this into an atom of chlorine. How do we get something that is negative and make it become something that has no charge, an atom that has no charge? What we do is this must release the electron. So there is a negative charge being released. So the chloride ion forms an atom releasing an electron. This electron now is free to go. We must remember the rule that chloride ions are diatomic, therefore we need 2 atoms and we need 2 ions, and that means they will release 2 electrons. Okay. Now one of the things we're going to talk about next is how we identify these 2 reactions that are taking place at the electrodes as either oxidation or reduction. Okay, so we have to identify these reactions at the electrodes as either oxidation or reduction. To help us to do this, we're going to use the word OILRIG. Now OILRIG stands for oxidation is loss, reduction is gaining. So oxidation is loss of electrons, reduction is gaining electrons. And if we use this in this number line to help us show this, if I started off down here and headed this way, so what I'm doing here is making this more positive, so going from negatives to 0 to positives, then in terms of negative electrons, in terms of negative charge, I am losing negative charge. I am becoming more positive because I'm losing negative charge. If I'm losing negative charge, oxidation is loss, then this situation would be oxidation. If I go the opposite way, so if I start from something being positive and heading towards 0 and then towards negative, what I'm doing here is becoming more negative. Therefore, I am gaining negative charge or gaining electrons. And if I come back to this, gaining is reduction. Reduction is gaining. So the type of reaction taking place here is identified as a reduction reaction. So if I apply this to my little equations from earlier, then what I've got here is a positive ion gaining an electron, therefore forming sodium. Because this is gaining the electron, this is reduction. This is an example of a reduction reaction. The sodium ion is being reduced to form the sodium atom. This example, this tends to be one that traps people and tricks people. You've got a negative ion that's now becoming neutral, no charge, and these electrons are released. I know it says plus electrons, but these electrons are now no longer part of the chlorine. They are being released, they're being lost. So the fact they are being lost means that this reaction is oxidation. So what I'm going to ask you to do now is, using this information that I've just explained to you, if you turn in your books to page 156 and 157, I would like you to complete the activities that are going to ask you to think about what is meant by oxidation, what is meant by reduction, and then to complete the equations to show, use an example of sodium chloride as we've done today to show what is happening in terms of electrons. Okay, you can watch the video again, so that if you need to go back over things, you can watch it, listen to it again, to support you with your work. And just remember these equations here, because it's only giving us half the information. So this one's only dealing with the sodium, and this one's only dealing with the chlorine. These are referred to as half equations. Okay? Good luck with the work. Watch the videos again if you need to, and have a think about your answers.